Video 9.6, completing the square. So, we have looked at a bunch of quadratics, some that are really easy to factor, some that are perfect squares, and today we're going to look at some that are actually pretty difficult and kind of turn out with some messy numbers. So we're going to learn a procedure to make those into easier problems to deal with. So what we've seen so far, we've seen quadratics such as x squared plus 6x plus 9. And using the box method, this is pretty easy to factor out. We know if we have x squared there and 9 goes in our bottom box, this is going to be a perfect square because if we have 3x, so that means x plus 3, x plus 3, where we have 3x and 3x adding to 6, multiplying to 9. We've also dealt with other problems such as x squared plus x minus 6, where we have to come up with something that multiplies to 6, negative 6, and adds to a positive 1. Since we have a negative constant, we know that one of our roots is going to be negative, one is going to be positive. So if we think about the factors of negative 6, we have 2, 3, 1, and 6, and a positive 3 and a negative 2 would make that a positive 1 in the sum. So today we're going to look at problems that are a little bit more difficult, that maybe don't factor as nicely. So maybe something like x squared plus x minus 1. We can't really think of anything that would, or two nice numbers that would multiply to a negative 1 and add to a positive 1. So we're going to learn how to solve questions like that today. And to do those, we have some steps for completing the square. These probably won't make sense to you as I go through them the first time, but if we come back to them after we've gone through a couple problems, then maybe they'll make a little bit more sense. First, we're going to set y to 0, so we're going to get all of our numbers and variables on one side. Then we're going to move the constant term over to the other side of the equation, factor out a leading coefficient, and I'll go through that, complete the square, and then balance, and then refactor or finish up your problem. So again, these probably don't make sense now, but we'll come back to them after we do a couple. So example A is to convert from general form to vertex form by completing the square. We're given the quadratic y equals x squared plus 12x minus 21. All right, so if I go through my steps, first I have to set y to 0. So if I put 0 equals x squared plus 12x minus 21. Then I'm going to take my constant to the other side. So I'm going to add 21 to both sides. And we have 21 equals x squared plus 12x. And first of all, we should probably talk about, are there any whole numbers you know of that multiply to negative 21 and add to a positive 12? The fact that there are no nice numbers that do that, that's why we're using complete the square to answer this problem. If this were a problem where we could easily factor, then we would do that for sure. Okay, so now we have 12x plus, or x squared plus 12x. And what we do in that case is we look at, and I like to use the boxes to help me out here. We look at, if we have this, what are we going to use so that these two boxes add to 12x? So obviously 12x divided by 2 would give us 6x here and 6x there. So if we're going to complete the square, we're going to have 6x, 6x, and then obviously here would be 36. So what I'm going to do is I'm going to add 36 to this equation. And that's going to make this really nice. It's going to say, okay, now this could just be written as x plus 6 squared, right? So, since we've done that, we've manipulated this side of the equation. And we learned when we were solving equations, what you do to one side, you need to do the other side. So we have to add 36 to this side. Okay, so 21 and 36 gives us 57. So we now have 57 equals x plus 6 squared. And then if we want to write that in vertex form, we can get rid of the 57 and say x plus 6 squared minus 57. Okay? And then we can also solve for our roots. So if we go from here and we want to say, okay, what is x? If we solve for x when y is 0, then we can now take, we have 57 equals the quantity x plus 6 squared. Then we can take the square root of both sides. So the positive or negative 57, square root of 57, excuse me, is equal to x plus 6. And if we solve for x by subtracting 6 from both sides, then we have negative 6 plus or minus the square root of 57 equals x, which is going to be about 1.55 or negative 13.55 equals x. So to organize ourselves here, we started in general form, moved to vertex form, which gives us the vertex as negative 6, negative 57. Remember the x here is negative because we're subtracting a negative. And then we solved for the roots and found that x, this parabola will cross the x-axis at negative 13.55 and 1.55. Realizing that those are estimates, and if we wanted the exact numbers, we'd use the square roots, we can transfer that down into factored form here where we have the opposite of our roots added and subtracted to x. Example B asks us to convert from general form to vertex form by completing the square. So for this one, we're going to have a little difference here because if you notice right away, we have a leading coefficient of 2. So we're going to use this step, factor out the leading coefficient. Okay, so if you look back at what we just did, we set the y to 0, we moved the constant to the other side, we completed the square, balanced it out, and then rearranged in vertex form. So here we need to set y to 0, so 0 equals 2x squared plus 12x plus 21. We're going to move the constant to the other side, so 21 equals 2x squared plus 12x. And now we're asked to factor this leading coefficient out. So that means 2 times x squared would equal x squared. And then what times 2 would equal 12? So we're just going to pull a 2 out. And this one's pretty easy here. 2 times the quantity x squared plus 6x would factor us to 2x squared plus 12x. So this 2 times the 6x would give us that 12x. And now we can work with a leading coefficient of 1 here. Okay, so 21 equals 2, and then I'm going to leave some space here because we have to find the perfect square, complete the square here with x squared plus 6x. So if I draw my boxes, I have x squared, and then these two boxes have to equal 6x, so that's going to be 3x. And 3x, what goes here? Well, that would be 9. Okay, so we have x squared plus 6x plus 9. And then that is going to just give us x plus 3 squared. Alright, so we completed the square there. Now, we added a 9 to this equation, so we kind of we manipulated this equation without doing anything to the other side. I'm going to change this up a little bit, and in here, right when I added the 9, I'm just going to take it away as well. Okay, so I'm going to write minus 9 there. And why I'm doing that here and not over here is because you have to remember we factored out a 2 here. All right, so anything we do inside these parentheses has to be taken by a 2 before we do it on the other side. All right, so I'm going to distribute that 2 into our negative 9. So we have 21 equals 2 times x plus 3 squared. So that's my distributing there. And then plus 2 times a negative 9. So 21 equals 2. Okay, and if I want to move into vertex form, then I can just change this into a y. I'm going to subtract 21 from both sides. Oh, I made a mistake. This 21 should have been negative. And now I'm going to add 21 to both sides. And I have y equals 2 times the quantity x plus 3 squared plus 3. And that is my vertex form. Alright, I'm going to ask that you guys complete example C for class. We'll be going over this in class for sure. Miss Atwood will go over it as well. So don't fret too much about not getting it completely, but you're asked to identify when the projectile is on the ground, meaning that y equals 0. You're also asked to identify the highest point where it's reached. So I'm going to ask you, I'm going to challenge you a little bit there. What does that mean in terms of our equation? So remember these steps. Set y to 0, move your constant. Here you don't have a constant, so you're just going to leave it at 0. Factor out your leading coefficient. So your leading coefficient is going to be negative 16 if you can factor that out. And then complete the square. Remember to balance, and then you can factor to find those zeros. So try that one for class. We'll definitely go over it in class. Make sure you fill out the form and ask any questions right away that you have so we can address those in class.